So let's do this. Calculate delta S surroundings, delta S and delta S surroundings from the transfer of 5 joules of heat from cold room air at 25 degrees to a warm cup of coffee at 75 degrees. Is this spontaneous process spontaneous or not? First of all, let me ask you, is this going to be a spontaneous process? It is. Room temperature, cold air, transferring heat to a warm cup of coffee at 75 degrees Celsius. Third question. A, yes, B, no. Is it going to be spontaneous? A, yes, or B, no? Okay, more people said yes than no. Let's imagine what we have here, okay? I can't write on it anymore. Okay. So you have coffee at 75 degrees Celsius. That's a warm cup of coffee, right? Boiling is 100 degrees. And your room is at 25 degrees Celsius. According to this, you're going to transfer heat from the room. So your heat transfer goes this way, from the room, the cold room air at room temperature, to a warm cup of coffee. You know that's not going to be spontaneous, right? What happens to your warm cup of coffee? Eventually gets cold, goes to room temperatures. What's the spontaneous process? Heat going from your coffee to the room. So it's not spontaneous. It's not spontaneous. So do you expect delta S for this to be A, positive, or B, negative for the universe? Do you expect delta S for the universe to be positive or negative? What does the second law say? If the process is spontaneous, delta S is positive. Since this is not spontaneous, delta S is negative. Okay? It's a non-spontaneous process. So delta S is negative. Can we calculate delta S for this? Okay, let's calculate delta S for the room air. Pretty much you can assume the room air is more or less going to stay at 25 degrees Celsius, right? It's not going to warm up to 75. A cup of coffee is not going to make it heat up too much, right? So we can assume it's pretty much at 298 Kelvin. How much heat was transferred? 5, right? 5 joules. Did the room, according to this, you're assuming that heat was transferred from the room to the coffee. So what's the algebraic sign of Q of delta H for your room? Yeah, your room lost energy, right? It gave that energy to the coffee. So Q, heat from the room is negative. So negative 5.0 over 298 would be 5 divided by 298 is 0.017, okay? I'm just going to keep one extra digit, 0.0168, negative 0.0168 joules per Kelvin. As expected, the entropy of the room went down. Heat left the room, right? What happens to the entropy of your coffee? So what's the delta T for the coffee? Q equals C delta T, right? What's delta T for the coffee? Q over C, right? So delta T, how much heat? 5. Positive 5 joules went into the coffee, right? What's delta T for the coffee? I mean C for the coffee. What's the specific heat of the coffee? 4.18 joules per Kelvin per gram. Okay. I did not tell you how many grams of coffee we have, but a cup of coffee, approximately how many grams is that? Can you tell me? I'm just estimating here. Let's say a cup of coffee is, let's say your regular soda, 12-ounce cans, about the size of your soda can, 12 ounces. So what's 12 ounces in milliliters? 1 ounce is 30 milliliters. Okay, so 12 ounces times 30, 260. It's about, yeah, it's actually 255. If you do that, let's see. 29.57 times, oops, 29.57 times 12 ounces, right? 355. Is that right? 29 times 29.57 times 12 ounces, 355. Yeah, it's 355 on your soda can. Okay? So 355, so if it's mostly water, how many grams will that be? 355 grams, right? Water is 1 gram per mil. So let's do that. So let's assume you have 355 grams of coffee, 355 grams of water in your coffee, and it's pretty much just water. So what's our delta T? 5 divided by 4.18 divided by 355. That's 3.00337. Okay, so you can see it doesn't change very much, right? The temperature doesn't change very much. In fact, this temperature actually goes up, right? Positive. Why would the temperature go up? You're assuming heat went into your coffee, right? We're just pretending that the room transferred heat to your coffee. The temperature of your coffee went up by 0.0037. So it's within the sig figs of our temperature. We're going to say 75 plus 0.0037. It's not going to change very much. Okay? So what's delta S then for the coffee? It's delta H over T, right? It's pretty much constant temperature. So it's going to be plus 5.0 joules over, what's the temperature of your coffee? 348 Kelvin. So how much is that? Five divided by 348, 0.0144. 266 joules per Kelvin. Okay? So 0.0168 and 0.0144. What's the delta S total? That's system plus surroundings. Negative 0.0168 plus 0.0144 joules per Kelvin. And what would that number be? And remember, we only have two sig figs here, right? 0.0168 negative plus 0.0144, it's negative 0.0024. Okay? Negative 0.0024. Why should it be negative? Because we know it's not going to happen, right? We expect it to be negative. Okay? So S, entropy of the universe, gives us a guide as to whether something has a natural tendency to occur.